Hello guys, this is Vishnu and today our topic is the continuity of a function. Um, so Vishnu and let's get started. So let's understand what basically continuity of a function is. So continuity of a function is nothing but, I mean, if we will consider a function as a continuous if and only if at x equals to a, if and only if limit extends to a of f of x equals to f of x. So we will be provided with a f of x. F of x is an expression. We will give. Let's consider it as ax plus b for a while. Um, so this is a given expression, and at the limits extends to a, which is equals to f of a. So we will be replacing the x value with a in the equation, and the resultant value is f of a is equals to a into a plus b. So and according to this condition, it should satisfy the second condition, which is LHS should be equals to RHS, and which is also should be equals to f of a. So what are LHS and RHS over here? Which is nothing but the negative limit and positive limit of the given value a of x. Then this is considered to be as LHS and RHS, which is equals to f of a. And f of x is not continuous, is considered to be not continuous at x of x equals to a when f of x is discontinuous at x of a x equals to a. So when it is discontinuous, when let's say like this for discontinuous, LHS is not equals to RHS, but LHS equals to f of a and RHS equals to f of a, but LHS is not, no, not f of a. When LHS is not equals to RHS, that's it. Then we will have two values, I mean the roots, if we go in that way. So over here, LHS is not equals to RHS, then it's a discontinuous function, or LHS equals to RHS but not equal to f of a, and ultimately LHS, no, wait, LHS is equals to RHS but not equals to f of a, and also LHS is not equals to RHS and it is also not equals to f of a. Then in these cases, in these three cases, it's considered to be discontinuous. So let's go to the next slide. Algebra of continuous. So addition and subtraction of two continuous functions makes a continuous function. If you add and subtract two continuous functions, provided two continuous functions, it will provide us a continuous function. So product and ratio will also provide us with a continuous function, and denominator should not be equals to zero at the point where we are checking the continuity. Well, the product of two continuous functions will also give us continuous. So according to the second line, this ratio also continuous provided denominator is not equals to zero. Well, let's say consider f of a by g of a. At given intervals, limit x tends to a and limit x tends to a. X tends to a, where f of a and g of a are two individual. I mean, the both are two different functions or expressions provided to us. So when I mean, f of x in the initial stage, when it is if we substitute the values of a into the respective expressions f of a by g of a, if g of a after I mean after replacing x in the expression with the a, then it will give us, if we get 0, then it results into f of a by 0, which we all know that it's like undefined, or sometimes it's also considered as infinity. Mm, so these are invalid functions. So in this case, it's invalid. So that's why the ratio is always continuous provided denominator is not equals to 0. at the point where we are checking the continuity. At the point in the sense which is nothing but the a value, what we are checking over here. And this is about the mentioned thing. And addition or subtraction of discontinuous function with the continuous function, it's always discontinuous. One is discontinuous and another is continuous. These both are different functions, and when we add or subtract, we'll get a discontinuous function always. And composition of two functions, two continuous functions is also continuous. So these are some a few points to remember. uh, Polynomial functions are continuous everywhere. Polynomial means normal ax plus b and ax square plus 2x plus b, something like that. And sin x, cos x, and mod x are also continuous everywhere. And that is the rest of the I mean trigonometric let's say like operations or things like tan, cot, sec, and cosecant. These all are continuous on their respective domains. I mean, um, at a particular time, I mean intervals, these all the tan, cot, secant, and cosec are continuous, and the rest and in another intervals, I mean the other intervals of their respective intervals, if we provide in if the question is of other intervals, then they are discontinuous. I mean, they got some fixed values for them to become continuous. But sin x, cos x, and mod x are respective to their limits. They are continuous everywhere. So log x is continuous at in the open interval of 0 comma infinity, where values from 1 to infinity minus 1, which is we don't know. Again, that's also considered to be infinity. Values are considered, and this is about these are a few points which will be handy. So let's solve a question. So over here, like if the function f of x is given by f of x, and I have provided three values of f of x at the respective intervals. If x is greater than 1, if x is equals to 1, this is, and if x is less than 1. So if x is greater than 1, the f of x value is 3x plus b, and f of x is goes, I mean, x equals to 1, then f of x equals to 7, and x is less than 1, which is 5x plus 2b. And if you have observed these things, x is less than 1. So less than 1, there is 0, minus 1, and all are negative values. So this is considered to be as negative limit. And if x is greater than 1, so uh, greater than 1, they start from 2, 3, 4, and these all are positive values. So with this, we can say that, um, I mean, according to our above, the first slide is condition. Limit x tends to a positive f of x should be equals to limit x tends to a minus f of x should be equals to f of a. So from where did I get this equation? It's from the very first slide, which says that LHS should be equals to RHS equals to f of a. As I've given you the explanation, and a limit x tends to a f of x should be equals to f of a. And this is how we could able to write this equation over here. So the given equations at x a plus, we have considered first plus over here, then minus. Okay, no problem. Uh, at positive interval. So x is greater than 1. What's the f of x value? 3x plus b. So 3ax plus b should be equals to it. It's still in the like f of x. We have didn't convert it into f of a. So 3x plus b should be equals to at x of x tends to a negative. So negative interval, which is nothing but x is less than 1. So it's 5ax minus 2b. And when f of a, when we are considering f of a where x equals to 1, which is nothing but 11. So let's add I mean, let's consider the values of 1. I mean, we already know that the given function is continuous at x equals to 1. So let's substitute that value. 3a plus b is equals to 5a minus 2b is equals to 11. Yeah. Now we have two equations where with this 3a plus b is equals to 11 and 5a minus 2b is also equals to 11. So we can write them as 5m. Okay. 5a minus 2b is equals to 11 and 3a plus b is equals to 11. So with this we can let's say like if we consider this we have to go with minus minus minus. So uh, let's eliminate b over here. So for that what we can do is um, we will multiply. Oh sorry, control set is not working. Okay, we'll just write down the equations, which is 3a plus b is equals to 11 and 5a minus 2b is equals to 11. So I just want to multiply the very first equation with the minus 2 on both sides, so which results into minus 6a plus, sorry, it will be minus, because plus into minus minus, and minus 2b which is equals to minus 22, and over here 5a minus 2b is equals to 11. So now according to the rule, over here plus, so we will consider as minus, and over here minus is this, so plus, and over here plus is this, so minus. So if we do minus 11a, plus minus will get cancelled each other, and minus 22 minus 11, it's minus 33. um, is equals to a is equals to 3. So if a is equals to 3, let's consider a equation where 3a plus b is a bit simple, which is equals to 11, and you can happily substitute this value into this a. So it will be 3 times 3 plus b is equals to 11. So 3 times 3 is 9, b is equals to 11 minus 9. Okay, 9 plus b is equals to 11. If we take this 9 to the RHS, it will be 11 minus 9, where b is equals to 2. So therefore the values of a and b are 3 and 2, and this is the solution of a um, given question. So this is how you deal with the continuity of functions, and thank you.